Once you're able to write the equation of a line in y equals mx plus b form, you are able to then focus on some of the more special characteristics or special cases of linear relations. In this lesson, we will be focusing on those two special cases of parallel and perpendicular lines. And by the end of this lesson, or by the end of the video, you will be able to determine if a pair of lines is parallel or perpendicular simply by using their slopes and by focusing on the values of the slopes of the lines. So to start off, I've got two linear relations here, or two linear equations, and we're going to take these equations and we're going to graph them on the Cartesian grid that I have here on the side of my screen. So both of these equations are in y equals mx plus b format. This one here on the right is very clearly identifiable as being in that format. It's got a y equals an m value, the x, and then a b value. This equation here on the left-hand side, it doesn't look like it's in the right order, and it really isn't. The 2 and the 3x are just a little bit out of order. So what we're going to do is rewrite it in the correct order. So this would then become y equals negative 3x plus 2. So what we're going to do is we're going to take these equations and we're going to graph them onto the grid. We're going to use the slope y-intercept process to graph these equations. So what that means is we're going to start by identifying the y-intercept, or the b value, in the equation. So for this first equation, the y-intercept is a positive 2. So on my grid, I'm going to go to the y-axis. I'm going to find positive 2, and I'm going to put a dot or a point on the value of positive 2. So I went ahead and labeled the scale on both my x and y axes, and I simply just counted it out by 1. And so now I'm ready to put a dot on positive 2 on my y-axis. So that point is going to represent the y-intercept. So now we need to figure out the direction that we're going to move along the Cartesian plane. So we're going to go back to our equation and we're going to pay attention to the slope. So the slope of this equation is negative 3. Now if I were to rewrite that as a fraction value, it's really just negative 3 over 1. Remember that the numerator value represents your rise. And because my rise happens to be negative 3, that means I'm going to move 3 units down. My run is the value that I see in the denominator, and I happen to have a value of 1, so that corresponds to 1 unit to the right. So from the y-intercept that I plotted already on the grid, I'm going to move 3 units down and 1 unit right. So we're going to go back to the y-intercept, and from here we're going to go 1, 2, 3 units down and 1 unit to the right. So we're going to put our next point at the coordinate point 1 and negative 1. So let me put that in. And then we'll repeat one more time. We're going to go 3 units down and 1 unit right. So that would be 1, 2, 3, and 1 to the right. So I'm going to connect those points with a straight, smooth line. And there we go. So we've graphed our first line. We're going to do the exact same thing with the second equation. So the second equation was in the correct format, so we can go ahead and look for the y-intercept. So the y-intercept is going to be negative 1. So I'm going to go to my grid, and on the negative 1, I'm going to put a red dot. And then we can go back to the equation to identify our slope. And the slope happens to be negative 3, same as the first equation. So with a slope of negative 3, remember that's the same thing as saying negative 3 over 1. So that's going to tell us to move 3 units down and 1 unit to the right. So I'm going to go back to the red dot that I placed on my y-axis, and we're going to move on the Cartesian plane. So from here, we're going to go 1, 2, 3 units down, 1 unit to the right. So that's going to take me to the point 1, -4. So I'm going to go ahead and put a point there. And if I repeat to get another dot, well, what's going to end up happening is if I try to go 3 units down, I'm going to come off of my grid and off of the page. And I don't want to have to guess or estimate where the dots are going to be. So rather than extend the line in this down direction, I'm actually going to go back and try to use some of the space up here, because that's a lot of wasted space otherwise. So if I want to try to extend the line backwards and use up this space here, I'm going to go back to my first point, which was my y-intercept value, and I'm going to work backwards. So instead of going 3 units down, the opposite would be to go 3 units up. So I'm going to go 1, 2, 3 units up. And then instead of going 1 unit to the right, I'm going to go the opposite way and go 1 unit to the left. So that's going to take me to a point of -1 and 2. So that is where I'm going to place my third dot. And so now I have 3 points plotted for this equation, and I'm going to go ahead and connect them with a straight line. And there we go. So now I've got both equations plotted on the same Cartesian plane. So is there anything that we notice now that we see the lines graphed side by side? Well, the first thing I notice is that my lines are running in the same direction. They are both sloping or slanting in this kind of downwards direction, and they are moving in the exact same direction. So I'm going to go back over here and I'm going to write that down. The lines run in the same direction. And because they run in the same direction, these two lines will never meet. They will never cross each other. They will never intersect with each other. So I'm going to add that to my answer. They will never intersect. And the second question asks us, what do you notice about the equations for the lines? So if we go back and look at the equations that we plotted on our grid, the first equation was y equals -3x plus 2. The second equation was y equals -3x minus 1. So are there any similarities between the two? Well, yes. What I do notice is that the slope in the first equation was -3, or the m value was -3, and the slope in the second equation was also -3. The m value in the second equation is also -3. So these two equations have the same slope. So we're going to write that down here. The two equations have the same slope. So when you have two lines that are running in the same direction and that they will never intersect, these are special lines that we call parallel lines. In mathematics, we say that two lines are parallel if and only if the slopes are equal. So again, parallel lines are two lines that are running or pointing in the same direction, and because of this, they will never meet or intersect or cross each other. So knowing this, then, we can say that if line 1 is parallel to line 2, then the slope of line 1 must be equal to the slope of line 2. Same way, if you know the slope of line 1 is equal to the slope of line 2, then you can conclude that the line 1 is parallel to line 2. So these two vertical bars here, this is the symbol that we use in mathematics to represent two parallel lines. So let's try an example. We're given two equations and we're asked to determine if these two lines are parallel. So we know that if two lines are going to be parallel, they have to have the same slope. The first thing you want to check for before you can evaluate your equations, the equations must be in slope y-intercept format, which means they need to be in the format of y equals mx plus b. So if I take a look at my equations, I can see that this second equation here is in the correct format. It is in the format y equals mx plus b. So we've got an m value, we have our x, we have our b value. The first equation, however, is not in y equals mx plus b format. We have our x and y terms on the same side, and they really shouldn't be. So we're going to have to rearrange this equation and get it in the right format. And then once we've done that, we can pay attention and take a look at the slope values in each of the equations. For an equation in y equals mx plus b form, the y value needs to be by itself. So in this particular equation, I'm going to take this x value, this 2x value, and I'm going to move it over to the right-hand side. If I take the 2x and move it over, it's going to become a negative 2x. So the 6y is going to stay where it is. We have our equal sign. Then I'm going to have my negative 2x. And we still have a positive 12 on the right-hand side, so I'm just going to recopy that. So now everything is in the right order. We've got our y term, our equal sign, our m value, our x, and our b value. The only issue is that there is a number or a coefficient attached to my y variable. In proper y equals mx plus b format, like in equation number 2 over here, there is no number or coefficient attached to the y. So we need to get rid of this 6. And so in order to do that, I need to divide every single term in the equation by 6. So if I were to do that, that's going to leave me with y equals. So now I've got negative 2 divided by 6. Negative 2 divided by 6 is not going to divide out nicely, so instead we are going to treat this like it is a fraction. So it would be negative 2 over 6, and we want to reduce that and make sure that it is in lowest terms. So if I were to reduce that, that would actually be negative 1 over 3, and we still have the letter x. And then finally, we've got 12 divided by 6, which is a positive 2. So here is the equation, just rewritten in slope y-intercept format. So now I can take my two equations and compare them, and what we are comparing or paying attention to is the slope value, the m value. So remember that the slope value or the m value is the number that is attached to the x. So in the first equation, my slope is negative 1 over 3. So I'm going to write that down here. m1 is equal to negative 1 over 3. And in my second equation, my slope value is also negative 1 over 3. So I'm going to say that my m2 is equal to negative 1 over 3. So are the slopes the same? Yes, they are the same in both equations. So because the slopes are the same, we can conclude then that these lines are indeed parallel. So I'm going to say, therefore, the lines are parallel since m1 is equal to m2. All right, now it's your turn to give it a try. Here's a brand new example, two brand new equations. You are going to determine if these two lines are indeed parallel. Remember to check the formats of your equations before you make your final conclusion. You can go ahead and pause the video and try to work out the solution yourself, and then come back to the video when you're ready to see the answer. So if I check the format of my equations, the second equation is in the correct slope y-intercept format. It's in y equals mx plus b format. The first equation, however, is not. So it does need to be rearranged. And in order to get it in the right order, I'm going to take this 6x and bring it over to the right-hand side. So that's going to leave me with 8y equals negative 6x, and then I still have this minus 24 on the right-hand side. So now my terms are in the right order. The last thing I need to do is get rid of this coefficient of 8 that is attached to my y. So what I'm going to do is divide out every single term in the equation by 8. So that is going to leave me with y equals, and then I have negative 6 divided by 8. That's not going to divide nicely, so instead I'm going to treat it like a fraction, and I'm going to reduce the fraction, put it into lowest terms. So 6 over 8, if I were to reduce that, that would give me negative 3 over 4. I have my x, and then I've got negative 24 divided by 8, which is going to give me negative 3. So I've got my equation nicely isolated, and our second equation is nicely isolated. So now we're ready to go ahead and compare the slopes. So in equation number 1, the slope is negative 3 over 4. So I'm going to write that down. My M1 is equal to negative 3 over 4. And in my second equation, my slope is positive 3 over 4. So I'm going to write that down. M2 is equal to 3 over 4. So if we go ahead and compare our slopes, are they the same number, the same value? They are not. They look at first glance to be the same number, but M1 is negative 3 over 4, and M2 is positive 3 over 4. These are not the same numbers. So are these lines parallel? No, they are not. So we can go ahead and write a concluding statement by saying, therefore, these lines are not parallel since the slope of line 1 is not equal to the slope of line 2. Let's take a look at a brand new set of equations, and we are going to do what we did before and take our two equations and graph them on the Cartesian plane. So I'm going to start with my first equation here, y equals 1 over 3x plus 3. It is in the proper order. It is in the proper equation format, so I'm ready to go ahead and plot this on my grid. I'm going to start by identifying my y-intercept, which is a value of positive 3. So I'm going to go ahead to my graph or my grid, and I'm going to place a dot on my y-intercept value of positive 3. I also want to go ahead and identify my slope, and that's going to give me information about the direction to move on the Cartesian plane. So this equation has a slope value of 1 over 3. And then in terms of directions, remember the numerator or the top number is your rise. So we have a value of positive 1 in our numerator. So that means I'm going to move 1 unit up. A positive rise infers that you need to move in an upwards direction. My denominator has a value of 3, which corresponds to my run, so that's going to tell me to move 3 units to the right. So let's go over to our grid. I've already gone ahead and filled in my scale for my x and y axes, and I've also placed a point on my y-intercept, which was a value of positive 3. So now what I'm going to do is from this point, I'm going to map out the remaining points for my line following those directions that we just identified. So we need to move 1 unit up and 3 units to the right. So from this point, I'm going to go 1 unit up and then 1, 2, 3 units to the right. So I'm going to go ahead and place my second point at 3 and 4. And then I need to place one more point, so I'm going to trace out where to go. So from this second point, I need to go 1 unit up and 3 units to the right. So 1, 2. So now when I get to that third unit, I'm again coming off of the graph, and that's not good. But remember, like before, we do have a lot of unused open available space on the left-hand side. So instead, we're going to work backwards and try to get a point in this corner here. So I'm going to go back to my first original point, which was my y-intercept point at 3, and we're going to work backwards. So instead of going 1 unit up, we're going to go the opposite and go 1 unit down. And instead of going 3 units to the right, we're going to move the opposite way and go 3 units to the left. So 1, 2, 3. So that's going to take us to a point of -3 and 2. So here is my third point. I'm going to join those points together with a straight line. And there's my line. So we're going to go back now to the second equation and map out where we should go. So with my second equation, y plus 1 equals -3x, this isn't in the correct format. It's not in y equals mx plus b format. This +1 is on the wrong side, so I'm going to bring it over to the right-hand side. And so that's going to give me an equation of y equals -3x minus 1. So now we're good to go. So my y-intercept is a -1, and my slope is going to be a -3. So I'm going to rewrite that as -3 over 1, and that tells me that I need to move 3 units down since it is a -3. And in the denominator, I have a 1, so that's going to tell me to move 1 unit to the right. So let's go over to our grid. We're going to start by placing a value or a point on our y-intercept, and our y-intercept was -1. So I'm going to go ahead and put a point there on -1. From there, we're going to use our directions from our slope to figure out where to go next. So we need to go 3 units down, 1, 2, 3, and 1 unit to the right. So that's going to take us to 1 and -4. So I'll put a dot there. And then if I repeat this, I need to go 3 units down, but again, I'm going to come off of the grid. So again, we're going to work backwards to try to use up some available space. So I'm going to go back to my original point, my y-intercept at -1, and instead of going 3 units down, I'm going to go 3 units up. 1, 2, 3. And instead of going 1 unit to the right, I'm going to go the opposite way and go 1 unit to the left. So that's going to take me to -1 and 2. So now I've got 3 points. I'm going to join them together with a straight line. Okay, so once you've joined your points together with a line, what we can see here is that we've got 2 lines that intersect, and they intersect at this point or this spot right here. So let's take a look at our follow-up question. And it asks us, well, what do you notice about the intersection of this pair of lines? So if I go back to my picture and take a closer look, there is something very specific about the way that these lines intersect. And it happens to involve the angle at which they intersect. These lines intersect at a 90-degree angle. So So they form a right angle at their point of intersection. So let's go ahead and write that down. So the lines intersect at a 90-degree angle. And remember that in math, we represent or show that we have a 90-degree angle by using a little square in the corner of that angle. Lines that intersect at a 90-degree angle are called perpendicular lines. So in math, perpendicular lines are represented by a symbol that looks like an upside down T. So we know that two lines are perpendicular if and only if the product of their slopes is -1. So yes, while we do know that they will intersect at a 90-degree angle, if we were to specifically focus on the value of the slopes of those lines, if we multiplied those numbers together, if we multiplied their slopes together, that is, we would get a value of -1. So therefore, we can say that line 1 is perpendicular to line 2 if the multiplication of their two slopes gives you -1. Similarly, if I take the slope of one line and multiply it with the slope of another line, and I happen to get -1, then I can conclude that line 1 is indeed perpendicular to line 2. When we multiply slopes together and get a value of -1, we can say that the lines, or that the slopes of those perpendicular lines, are negative reciprocals. Well, negative reciprocal is kind of a fancy term, but if you wanted to really find out if something was a negative reciprocal, or if two values were negative reciprocals, really all you have to do is take one number, you're going to flip it, and change its sign. So let's practice a little bit with that. Example number 2 asks us to identify what is the negative reciprocal of each of the following numbers. So let's start with our first value here. We have a value or number of 2. So if I was going to figure out the negative reciprocal of this number, the first thing I need to do with this 2 is flip it around. So what do I mean by that? Well, let's write 2 as a fraction. Well, 2 is really 2 wholes. So as a fraction, I could write it as 2/1. Same thing. So if I had to flip this number, or this fraction, it would become 1/2. So once I flip it, the second step is I need to change the sign. So right now, this is a positive 1/2. If I change the sign, a positive would become a negative. So the negative reciprocal of 2 happens to be -1/2. Let's try that with the second value. So this time we have a value of 1/10. So to come up with the negative reciprocal, the first thing we need to do is flip this fraction around. So if I flip it, it's going to become 10/1. Now, if you have a 1 in the denominator, you don't necessarily have to write it. So you could also just simply state it as being 10. Step 2, once you've flipped the number, you need to change its sign. So this is a positive 10/1, or a positive 10. So if I have to change the sign, it's going to become a negative 10. Positive will change to a negative. And we've got one more example here. We've got a value of -1/4. So the first step is to flip this over. So if I do that, I'm going to get -4/1. Or we can simply just say that it is -4 because, again, we don't have to include that 1 that's in the denominator. So we flipped it. The second step is to change the sign. So this is already a -4. So if I want to change the sign, it's going to become a +4. So the negative reciprocal of -1/4 is a +4. So something, if we go back and take a look, if we started with a positive number, our negative reciprocal ended up being negative. Same in question B, we started with a positive number, our negative reciprocal ended up being a negative number. But when we start with a negative number and take the negative reciprocal, we end up with a positive number. So in order to find a perpendicular slope, we need to focus on finding or identifying the negative reciprocal. So that's what we're going to do in this next example. We want to determine if these two lines are perpendicular. So same like before, the first thing you always need to check for is that your lines or equations of your lines are in y equals mx plus b format. So when I take a look at the lines here, the first equation is good to go. It's in the right format. The second equation is not. So this equation is going to need to get some rearranging. And then once we've done that, we can compare the slopes. So to begin with, I know that this positive 3x is on the wrong side. It needs to come over so that way we can have just the y left over on the left-hand side. So once I bring that 3x over, I'm going to be left with 3y equals -3x plus 9. And then to isolate for the y, we need to divide every single term in the equation by 3. And so that's going to leave us with y equals -1x plus 3. Now again, remember that you don't have to include this 1 in front of your x, so I'm actually going to remove it. And I'm just going to leave my x term as -x. All right, so now we're good to go, and we have both of our equations in the correct format. So we're going to go ahead and compare the slopes. So in equation number 1, the slope, or the m value, is 2/3. So I'm going to write that here off on the side. m1 is equal to 2/3. So now, if equation number 2 is going to be perpendicular with equation number 1, the rule states that the slopes need to be negative reciprocals, which means if I take the slope 2/3 and I turn it into its negative reciprocal, that should be the slope that appears in equation number 2. So let's just do that work. Let's turn 2/3 into its negative reciprocal. So to do that, I need to flip 2/3, which turns it into 3/2. And I need to change the sign. So we started with a positive 2/3. If I change the sign, it's going to become a negative 3/2. So let's check and see, is this slope, negative 3/2, the slope that appears in our second equation? So if I go over to my second equation and I look at the slope, well, the slope here is a -1. It is not negative 3/2. So these two slopes, 2/3 and -1, they are not negative reciprocals. So because they are not negative reciprocals, these two lines are not perpendicular. So we can write a concluding statement and say that these lines are not perpendicular since their slopes are not negative reciprocals. All right, now it's your turn to give it a try. Here are two brand new equations. You need to determine if these lines are perpendicular. Go ahead, pause the video, give it a try, and come back when you're ready to see the full solution. So when looking at these two equations, the first thing I noticed is that equation number 2 was not in the correct format. It wasn't in y equals mx plus b form. So I went ahead and I took the 3x term and I moved it over to the right-hand side. And then I isolated for y by dividing every single term by 4, which left me with an equation of y equals negative 3 over 4x plus 9 over 4. With questions like these, when you're trying to determine whether they are parallel or perpendicular, you really want to leave your terms as fractions if they do not divide nicely. It's going to make it easier for you to compare the slopes, and especially in this case, when we're trying to figure out if the slopes are negative reciprocals, it's going to be much easier for you to identify that if you leave your numbers as fractions. Of course, make sure your fractions are reduced into lowest terms. Same thing with your b value. No reason to make this a random decimal number. Keep it as a fraction reduced to lowest terms as well. So now we've got our two equations in the correct format, so I'm ready to go ahead and compare the slopes. So in my first equation, I noticed that the slope is 4 over 3. So I went ahead and wrote that out. Now, the next thing I want to do is figure out what is the negative reciprocal of that slope. So I'm going to have to first start by flipping it over. So 4 over 3, if I flip that, it's going to become 3 over 4. And then the second step is to change the sign. So right now this is a positive 4 over 3. If I want to change the sign, it's going to turn that positive into a negative. So the negative reciprocal of 4 over 3 is negative 3 over 4. So now let's check our second equation and see, are these two slopes the same? So if I go to my second equation, I see that yes, the slope in the second equation is indeed negative 3 over 4. They're the same. So M2, or slope 2, is negative 3 over 4. So M1, with a slope of 4 over 3, its negative reciprocal shows up in equation number 2, negative 3 over 4. This means that these two lines are indeed perpendicular lines. So we can conclude that the lines are perpendicular since the slopes are negative reciprocals. Here's one more chance for you to get some practice in. You are given two slopes for two different lines. You need to conclude or determine if the slopes are parallel, perpendicular, or neither. It is possible for your slopes to not be parallel, or they could also not be perpendicular. So pause the video, try it out, and come back and check your answers. So with the first set of numbers, the first slope is a value of 3, and the second slope is a value of negative 1 over 3. So right away, I know that they're not the same number. Because they're not the same number, that means that these lines cannot be parallel. Because remember that if two lines are parallel, their slopes are the same. They are identical. These two numbers are clearly not the same. So these two lines are not parallel. So now let's check if they are perpendicular. So if I start with a number of 3, I need to flip it over, which is going to turn it into 1 over 3. Because remember, this was the same thing as saying 3 over 1. So I flipped my number, and then I need to change the sign. So this started off as a positive 3. If I change the sign, that means I need to make it a negative number. So we get negative 1 over 3. Oh, and look, that is the number that shows up for line number 2. So these two slopes happen to be negative reciprocals. If they are negative reciprocals, that means that these two lines are indeed perpendicular. Let's take a look at the second set of numbers. We've got 2 as the slope for line 1, and we've also got 2 as the slope for line 2. So because the slopes are exactly the same, they are identical, that automatically tells us that these lines are parallel. In our last set of numbers, we have a slope value of negative 4 for line 1 and we've got a slope value of negative 1 over 4 for line 2. So right away I know that these slopes are not the same number. It's not the same number showing up twice. So these lines are not parallel. So now we can go ahead and check if they are perpendicular. So I'm going to start with my first slope, which was a value of negative 4. So I need to check the negative reciprocal. So I'm going to go ahead and flip this over. So that's going to give me negative 1 over 4, because remember this is the same thing as 4 over 1. And the second step is I need to change the sign. So we started off with a negative 4. So if I change the sign, that means I need to turn this into a positive number. So the negative reciprocal of negative 4 is a positive 1 over 4. So now let's go ahead and check that or compare it to the slope of line number 2. So we got a negative reciprocal of 1 over 4. However, the slope of line 2 is a negative 1 over 4. So negative 4 and negative 1 over 4, those are not negative reciprocals. So because they're not negative reciprocals, that means that these lines are also not perpendicular. So they're not parallel because the slopes are not the same. They're not perpendicular because these slopes are not negative reciprocals. So that means that they are neither. So they're not parallel, they're not perpendicular. Perhaps they just intersect in some other way. So just to wrap everything up for you, we can say that two lines are parallel if we see lines that run in the same direction, and we know that the lines will never cross or intersect with each other because they are running in the same direction. If we were to look at their equations, the equations of lines that are parallel have slopes that are the same. If we are talking about perpendicular lines, we are talking about two lines that cross or intersect each other at a 90-degree angle. If we are looking at their equations, the slopes of perpendicular lines will be negative reciprocals. So again, remember that means that if you take the slope of one line and you multiply it by the slope of the second line, it should give you a value of negative 1. Again, to find or determine a negative reciprocal, you can take a given number, you're going to flip it over, and then you're going to change the sign. So if you start off with a positive number, your negative reciprocal should be negative. If, however, you started off with a negative number, so let's say it was a negative 2 over 3, when you change the sign, you should end up with a number or a slope that is positive.